4.7. This is entitled Identity and Inverse Matrices. So there's going to be a lot of definitions and things in here that we haven't discussed before with matrices. So the first few slides are just going to be kind of some introduction and some definitions for this. So the first thing, it's a square matrix that when multiplied by another matrix equals the same matrix. So just like when you have multiplication identities, when you do like 5 times 1 and you still get 5, this is the exact same thing. When you do any matrix times its corresponding identity matrix, you're going to get the exact same matrix. And as you notice, with both 2 by 2s, 3 by 3s, and then continuing on, the diagonal starting in the upper left and going down to the lower right is all 1s, and everything else is 0s. So again, when you multiply a matrix by its identity matrix, doesn't matter whether it's before, whether it's after, you will get the exact same matrix. So here's just an example with some variables in there. When you multiply it either on the left or the right, you get the exact same matrix. And then an inverse matrix. Again, when you have 5 times 1/5, those are multiplicative inverses, and when you multiply them, you get 1. Same thing with matrices. When you multiply two inverse matrices, you should end up with the identity matrix. So you should end up with that same matrix we were just looking at. So here we have, again, they are square matrices. They must be squares when you're doing these things. And we denote it with a to the capital A to the -1, or whatever matrix letter you've assigned it. You put that -1 almost as an exponent, but it's indicating the inverse. So let's take a look at example number 1 here. They're asking us if these are going to be inverses of one another. So what we want to do is we want to multiply these two things to determine if indeed we get the identity matrix. So let's multiply 2, 2, -1, and 4 by 1/2, 1/2, -1, and 1/4. So again, matrix multiplication. Just a reminder, moving across this row and down these ones. So we have 2 times 1/2 is 1. 2 times -1 is -2. So we have 1, and -2 is -1. Then we have 2 times 1/2 is 1. 2 and 1/4 is 1/2. So 1 and 1/2 is 3/2. As you can see, these are not going to be inverses, because when we're multiplying them, we're getting things that aren't 1s and 0s. So really, you don't have to continue here because we're not getting the right answers here. So let's go down here and we're going to see if these two are inverses of one another. I'm going to move it off to the side here to have some room to write. So we're going to have 3, 4, 1, 2. And we're going to multiply that by 1, -2, -1/2, and 3/2. So when I multiply this, we have 3 times 1 is 3, plus 4 times a -1/2 is a -2. So 3 and -2 is a +1. So far so good. 3 times -2 is a -6. 4 times 3/2 is going to be 6. So a -6 and a +6 is 0. And we have 1 times 1 is 1. 2 times -1/2 is a -1. So 1 and -1 is 0. We have -2 and a +3, because 2 times 3/2 is 3. So -2 and a +3 is a +1. And this checks out because we do get that identity matrix. So when you're actually finding a matrix, the inverse matrix, we're going to go back to using the determinant. So I told you that determinant would come up several times throughout the rest of this chapter, and here's another one of those uses for the determinant. If you notice, finding the inverse, we put 1 over that determinant, because that determinant is the multiplication of a times d and minus that b times c. What you do after, so that creates a fraction as a scalar in front here. after you find the determinant, you switch the A and the D. So now D is here and A is here. The B and the C stay in the same location, you just create negatives. So the A and the D switch, the B and the C switch signs. They become negatives now. And so that's how you find the inverse. So let's go through and do some examples of finding inverse matrices. So when we want to find the inverse, again, we're going to start with that cross multiplication here. So we're going to have 1 over negative 4 times 6 minus a negative 3 times 8. And then the matrix I'm going to have here, I'm going to switch the 6 and the negative 4, and I'm going to change the signs of the 8 and the negative 3. So now it's negative 8 and a positive 3. So here I'm going to multiply this out. We get 1 over a negative 24 plus 24 everything here stayed the same. Notice negative 24 plus 24 gives us 0. We cannot divide by 0. So when that happens, it's your favorite answer. It does not exist. This is undefined. There is no inverse. And that'll happen sometimes. Sometimes equations won't have inverses. Or matrices won't have inverses. So that one was kind of a bust. So let's take a look at the next one here. So again, cross multiply. So we get 1 over 3 times 2 is the 6. 1 times 5 is 5. So 6 minus 5. That's not going to be 0. So we know we'll have an inverse here. So we're going to switch the 3 and the 2. So now 2 is up here and 3 is down here. And then just change the signs of the 5 and the 1. So we ended up with 1 over 1, which is just 1, 2, negative 1, negative 5, and 3. Now you can, really we don't want to multiply through by that. Since it's 1, it's going to stay the same. So this ends up being our inverse matrix, that switch around that we had there. That's all let's do it. That's how you find an inverse matrix. Alright, so let's try one more. So again, start with that cross multiplication. So we have 1 over negative 2 times negative 1 is a positive 2, minus 8 times 0 is 0. So this time we're not going to end up with a 1, so we'll see what happens with that this time. Switch these two, signs stay the same, but we just switch them around, and we switch the signs. 0 can't change signs, so we just say 0, and we have a negative 8. So this is going to end up being 1/2 times this matrix. And what we want to do is we want to multiply through by the scalar. We want to multiply through by the 1/2, so we end up getting 1/2 times negative 2 is a negative 1. 1/2 times 0 is 0. 1/2 times negative 8 is a negative 4. And 1/2 times negative 1/2 is negative 1/2. And this is what we call the inverse of A, or A to the negative 1. And that's it. There's your homework, page 213, 9 through 21 odd. We will be working on that tomorrow in class. So make sure you have your things with you to review inverses and identities and to work on 9 through 21 odd.